Hello and welcome to my lesson, Numbers and Operations, Part 1. In this lesson, we are going to talk about two different sets of numbers. First of all, we are going to talk about the natural numbers, so we will define them, and we will move to another topic to discuss the value of a digit according to its position in a natural number. Second, we move to the set of the integers. We first start by defining integers. Then we move to representing the integers on the number line. Then we talk about the operations, the mathematical operations performed on integers, the addition and subtraction, and then multiplication and division. Finally, we talk about the exponents on integers. So natural numbers are those numbers that are used for counting things. For example, I have 3 apples. I have 3 cars. I live on the 3rd floor. We use the letter n to refer to the set of natural numbers, and it's an infinite set, so that it starts from 0, then 1 and 2 and 3, and it moves to infinity. It doesn't reach an end. We use n with a small star on the top right corner of the letter to refer to the set of natural numbers without 0. It's good to mention here that not all mathematicians agree whether 0 belongs to the set of natural numbers. That's why if you are a student, better to talk to your teacher to see how 0 is treated throughout the context of their lessons. We denote n as follows, between 2 brackets, a list of numbers starting from 0, then 1 and 2 and moving to infinity, and n with star, which is the set of natural numbers without 0, starts from 1. Notice that we excluded the 0, then 2, 3, 4, and it moves to infinity. We can similarly denote this, represent this on the number line, starting from 0, then 1, 2, 3 to infinity, in the case of the natural numbers, and starting from 1 and moving to infinity in the case of natural numbers without 0, or what we call n star. Let's move now to talk about the concept of value of a digit according to its position in a natural number. Each digit, we mean by digit a number from 0 to 9, has a value according to the position it belongs to in the natural number. For example, if we took an example, this number, 3,216,754, we notice that this number has 7 digits, and each digit falls in a position according to its location in the number. For example, digit 4 falls in the position of ones, meaning that the value of 4 is 4 multiplied by 1, which is 4. In the case of the second digit, which is 5, it falls in the position of tens, meaning the value of the digit 5, in this case not 5, but 5 tens, or what we can say 50. And similarly, this goes for the other digits. For example, the value of 7 here is 7 hundredths because it falls in the position of hundreds. This number we started with can be written as a sum of the values related to the digits that form this number. So here, we start with the value of 4, which is 4. Then we add the value of 5, which is 50. Then the value of 7, which is 700. And we move on until we reach the last value, which is the value of 3, the digit 3, which is 3 millions. Summing those numbers gives us the initial number we started with. So let's perform a test. What is the value of 9 in this number, 8,596. We notice that 9 here falls in the value of tens in the table we were discussing in the previous slide. So its value is 9, tens, or 90. So the answer is 90. It falls here. Now, in the case of 0 in the number we see here, we notice that 0 falls in the position of hundreds. So its value is 0 hundredths, which is 0. Let's move to the third number to see what is required here. Write the number 2,433 as a sum of values as shown on the previous slide. So we start filling the tables with the digits and we write the sum accordingly. So this 3 falls in the position of ones. The second 3 falls in the position of tens, then 4 falls in the position of hundreds, and finally 2 falls in the position of thousands. So this number that we started with, 2,433, could be written as a sum of the values of its digits. So it is 3 plus 30 plus 400 plus 2,000. If we sum these together, we will get back to our initial number. So let's move now to talk about the set of integers. The set of integers is divided into positive integers and negative integers. The set of positive integers is the same as the set of natural numbers we have seen before, and it starts from 0, then 1, 2, 3, and it moves to infinity. Negative integers represent the opposites of the natural numbers. So for example, if we have plus 2 is a natural number, which is also a positive integer, then minus 2 is the negative integer that is opposite to this natural number, and or that is opposite to this positive integer, and we call these two numbers opposites. The set of negative integers moves from infinity, then minus 3, minus 2, moves here minus infinity actually, minus 3, minus 2, minus 1, and then 0. Here, of course, we have, for example, minus 2 is smaller than minus 1. So as we move to the left, the integer numbers get smaller. Negative integers could be present in our daily life in different contexts. For example, the temperature degrees are measured relative to a starting point that is 0 Celsius. So on a summer day, you might hear that the temperature is plus 20 degrees. However, on a snowy winter day, you might hear that it is minus 5, minus 10, or even below. In other contexts, we might find it, for example, if we are measuring the location or the altitude of cities relative to the sea level. So if we consider the sea level as a starting point, we might find some cities are located on a distance above sea level, whereas other cities are located on a distance below sea level. In our case here, this city is located 300 meters above the sea level. However, this city here is located minus 100 meters below the sea level. We might use the negative numbers also in financial context. For example, if I have zero money or $0 at first, then I get 4 euros. So I can represent this by +4. So in this case, we use the integers and specifically the positive integers to represent the increase of dollars that I got. However, if I spend 1 euros out from these 4 euros that I have here, then I will end up with 3 euros. And here we used -1 to represent the decrease that happened on the initial amount of money I had, which is 4 euros. Now let's see how we refer to the sets of integers and the partial sets of the integer set. We refer to the set of integers by z, as we saw before, and it starts from -infinity. It goes to -2, -1, 0, 1, 2, 3, and it goes again to infinity. We refer to the set of integers without 0 by z with a small star on the top right corner. This means the previous set with 0 excluded, as we can see here. It's exactly the same as before, but with no 0 included. We refer to the set of positive integers by z with a small plus on the top right corner, and this is the same as the set of the natural numbers, which we talked about before, and it starts with 0, then 1 and 2, and it moves to infinity. Similarly, the set of negative integers is represented by z minus, starting from -infinity and moving to -3, -2, -1, and ending with 0. We refer to the set of positive integers without 0 by using a small star next to the plus. So it is z plus star, and this is the same as n star. And we refer to the set of negative integers without 0 by z minus star, and it starts from -infinity and it ends with -1. Notice that we have excluded the 0. Now let's do a simple test. Use a signed number to represent each situation. So we have to write what each phrase means using plus or minus, then a number. The price of a certain book rises by $10. So this could be represented by +10. We have here the temperature of the freezer is set to 15 degrees below 0. So if 0 was the starting point, then 15 degrees below 0 is represented by -15. 5 points are deducted from a student's score in a test. So the student scores goes 5 points down. So we represent this by -5. The number lines, we can represent integers on the number line. So we notice that the number line has 0 in the middle, and it goes to -infinity from the side of the negative integers and to +infinity from the side of the positive integers. We notice that if 0 falls in the middle of a distance between two integers, this means that those two integers are opposites. For example, here 0 falls one step away from -1 and one step away from 1. So in this case, 1 and -1 are opposites. Same works for 3 and -3. Same works for 4 and -4, and so on. Just a small note that the positive integers don't need to include the plus sign next to them. We can just write 2, for example, instead of +2. If we want to compare two integers, using the number line, we notice that the number that falls on the right side always has a bigger value than the number that falls on the left side. For example, here 3 is bigger than 2. We notice that 3 falls on the right side of 2, so 3 is bigger. 0 is larger than -5, so here 0 falls on the right side of -5, so it's 0 is bigger. -3 is larger than -5, again here is -3, it falls on the right side of -5, so it's bigger. Let's take an example. Arrange the following in ascending order. So we have 6 integers and we want to arrange them in ascending order. First of all, we have to see the negative numbers or the negative integers and to sort them. So we have here -1 and -4. Since -1 falls on the right side of -4, so -1 is larger than -4. So -4 is the smallest among this set we have, followed by -1. Now we look at the rest of numbers, which are all positive integers. We notice that 1 is the smallest, followed by 2, then 5, then 8. Simple. Now we need to do the same exercise, but we have to arrange the numbers in descending order. So we have to start by the largest. For this reason, we start looking at the set of the positive integers. So we have 5, 8, 2, and 1. We arrange them in ascending order. We arrange them in descending order. So we start by 8, then 5, then 2, then 1. Now we finish the set of positive integers. We start sorting the negative integers. We notice that -1 is larger than -4, so we put -1 first. Then we finish with -4. Now let's talk about addition of integers using the number line. So when adding a positive number, we move to the right. For example, here we have -5 plus 6. We are adding a positive number, which is +6. So first of all, we take the first number and we locate it on the number line. It's -5, it's here. And then we move 6 steps to the right of -5. So 1, 2, 3, 4, 5, and 6. We finish here. So the result in this case is -1. On the other hand, when adding a negative number, we move to the left. So here we are adding -7, which is a negative number. We start by looking at the first number, which is 4, and we locate it on the number line. So here is 4. We have to move 7 points to the left because we are adding a negative number. 1, 2, 3, 4, 5, 6, and 7. We finish here at -3. So the result is -3. Let's learn a faster method to add 2 integers, because sometimes we might have very big integers, like, for example, 5,112 minus 6,154. So this is impossible to represent on the number line. So in this case, without using the number line, if we have 2 numbers with the same sign, we keep the sign and we add the numbers. For example, here we have -3 plus -4. They are both negative. In this case, in order to sum those 2 numbers, we keep the sign, which is minus, and we simply add 3 to 4, so we get -7. In the case the two numbers have a different sign, we use the sign of the largest number and we subtract. So for example, here we have -3 plus 4. They have different signs. We use the sign of the biggest number, which is plus, and we subtract 3 from 4, so the result is 1. In the last example, we are adding two integers with different signs. Since 7 is larger than 3, we keep the sign of 7 and we subtract 3 from 7, and this gives us -4. We notice that in the case of addition, we can ignore the brackets here. So simply we can write -3 between brackets plus 2 plus -4 between brackets as -3 and -4 directly. Addition properties. If a and b are integers, then a plus b equals b plus a. Let's take an example. +7 plus -8 must be equal to -8 plus +7. Let's see if this is true. Here, we notice that we are adding two numbers of different signs. So we keep the sign of the biggest number and then we subtract. So 8 minus 7 equals 1. Here also, we are adding two numbers of different signs. We keep the sign of the biggest number and we subtract. So we get -1. So they are equal. Another property, if we have three digits, a, b, and c, that are or integers, a, b, and c, then a plus b, adding them together, and then adding the result to c, is equal to calculating b and c, b plus c, like adding b and c together first, and then adding the result to a. So if we give an example, here, +7 plus -8. So if we calculate the result here, it will give us -1. Now adding -1 to -4 will give us -5. Now, instead of adding 7 to -8, we will leave 7 outside and add -8 to -4 like this. And the result will add it to 7. So -8 plus 4, we have two digits of similar sign. We keep it and we add. So here we got -12. We add the result to 7. So we have 7 plus -12, which is -5. We notice that the result is equal to the previous one and the property is satisfied. Subtraction of integers using the number line. For example, -1 minus +2. In order to find the answer, we take the first number, which is -1. We have it here. We locate it on the number line. And since we are subtracting a positive number, which is +2, we move 2 steps to the left. So from -1, we move 2 steps. We fall on -3. So the answer is -3. In the other case, we are subtracting a negative number. We notice here we have -2. So in order to find the answer in this case, we take the first number, which is 3. We locate it on the number line here. And we move 2 steps to the right. So starting from 3, move 2 steps to the right. We fall here, so the answer is 5 or +5. Now we are going to learn how to subtract without using the number line. In order to do that, we add the opposite of the number that is being subtracted to the number that we are subtracting from. For example, here we are subtracting -4 from -3. In order to perform this calculation, we need to add the opposite of -4, which is +4, to -3. So we get +1. Here it's a mistake, it's written mistakenly. So the result is +1. In the other example, we are subtracting 4 from -3. So to do that, we need to add the opposite of 4, which is -4, to -3, and the result is -7. Note about subtraction. The properties that worked for addition do not still valid in the case of subtraction. Give an example where a and b are integers and a minus b doesn't equal b minus a. For example, we have -4 here subtracted from -3, which is the same as -3 plus the opposite of -4, which is 4, and the result is 1. If we try to switch the locations of -3 and -4, so now -3 is subtracted from -4, which is the same as -4 plus the opposite of -3, which is 3, equals -1. We notice that the result is different. This means that -3 minus -4 is not the same as -4 minus -3. We can give an example where a and b are and c. Here we require 3 integers, and c are integers, and a minus b between brackets minus c doesn't equal a minus between brackets b and b minus c. So you can practice on this case as well in similar manner. Multiplication and division. When we multiply or divide two numbers having the same sign, the answer is positive. When we multiply or divide two numbers having different signs, the answer is negative. We have to note here that division by 0 is not possible. Let's give an example. -3 multiplied by 2. So here we are multiplying two integers with different signs, so the answer will be negative, -60. In the other situation, we are dividing -60 by -3, two integers with same sign, so the answer is positive, which is 20. Multiplication properties, same as we saw for the addition. If a and b are integers, then a plus b equals a multiplied by b is the same as b multiplied by a. If a, b, and c are integers, then if you multiply a and b first, then multiply the result by c. So this is the same as if we multiply b and c first and then multiply the result by a. For example, here +3 multiplied by -2. So plus and minus in multiplication gives us -3 multiplied by 2 equals 6. This is the same as if we put -2 first and multiplied it by 3. So the first property holds. Regarding the other property, we have 3 multiplied by -2 between brackets, then the result is multiplied by -4. So 3 multiplied by minus 2 gives us minus 6. We multiply this by minus 4, we get 24. In a similar manner, now we take 3 out, so it becomes 3 multiplied by, between brackets, minus 2 multiplied by minus 4. So minus 2 multiplied by minus 4 gives us plus 8. We multiply this by 3, so we get 24. So the second property is satisfied. Note about division. The properties that worked for multiplication do not still valid in the case of division. Give an example where A and B, either A doesn't equal 0 and B doesn't equal 0 are integers, and A divided by B doesn't equal B divided by A. For example, here we have minus 8 is divided by minus 4. Same sign, so it's positive. The result is positive, and 8 divided by 4 equals 2. However, if we switched the locations of the integers, so now we have minus 4 divided by minus 8, we get plus half, which is not equal to 2. This means that minus 8 divided by minus 4 doesn't equal minus 4 divided by minus 8. Give an example where A, B, and C, where B doesn't equal 0 and C doesn't equal 0 are integers, and A divided by B between brackets, then the result is divided by C doesn't equal A divided between brackets B divided by C. You can work on a practical example very easily as before in exactly similar manner, and you will reach the conclusion that this property does not stay correct in the case of division. Exponents on negative integers. As we learned in the previous levels, for example, 2 is raised to the power of 3. So this is equal to 2 multiplied by 2 multiplied by 2. This is equal 8. So if we take a negative number now and we raise it to a power, let's say here minus 5 is raised to the power of 2. So it's minus 5 multiplied by minus 5. This gives us plus 25. If we used 3 instead as a power to minus 5, so we get minus 5 multiplied by minus 5 multiplied by minus 5. So we multiply the first two minus 5s together to get 25, and we multiply the result by minus 5 to get minus 125. We notice that here 2 is an even number, so we get a positive answer. And when the power, which is 3 here, is an odd number, we get a negative answer. So as a general rule, an even exponent like 2 or 4 or 6 on a negative number gives a positive answer. And when an odd exponent like 1 or 3 or 5 on a negative number gives a negative answer.